Today we work with a very simple method for solving a differential equation. In the assignment that you saw yesterday, you saw some problems where you had an x and a y. And I just want to start right off with a problem like that. Let's say that I have dy dx equals xy, the quantity squared. And we want to solve that differential equation. Well, automatically you see that there's a problem because we have an x and a y. All right? Well, what we're going to do is the title of our lesson. We are going to separate the variables. All right, this boils down to a very basic algebra manipulation. All we want to do is get the x's on the x stuff on one side and the y stuff on the other. All right? So watch. First, we'll square this side over here. So now I have dy dx equals x squared y squared. dy dx equals x squared y squared. Now let's do some algebra, and we can just treat, by the way, it's very important to know that we can just treat this thing as a regular fraction, okay, for all of our algebra steps. So keep that in mind. We can just treat that like a regular fraction. So let's see. Why don't we multiply both sides by dx? Okay, dx times this side, dx times this side. On the left side, the dx's cancel. And now I have dy equals x squared y squared dx. And I just have one more step until I have my variables separated. Why don't we divide both sides by y squared now? Divide both sides by y squared. On the right side, they cancel. And on the left side, I now have, this is important to understand, this is 1 over y squared dy. All right, it's the same thing as 1 over y squared dy. On the right side, I just have x squared dx. Okay, so look what we've done. We have now separated the variables, and we are now ready to start solving this differential equation, just like we've done the last couple days. So now I just have y to the negative 2 dy equals x squared dx. And let's go ahead and put our integral in. We are now going to integrate both sides. All right. And let me get to a new page here because I'm out of room. So I have the integral of y to the negative 2 dy equal to the integral of x squared dx. Okay, that's where we are right now. So let's just go ahead and proceed with our integration here. On the right side, that's a simple antiderivative. It is x cubed over 3 plus c. Remember, we must get that plus c in there. Okay? And on the left side, even though that's a y, we're just going to treat it like we do the right side. We're going to use our power rule. So we add 1 to this negative 2 up here. So that's going to make that y to the negative 1 over negative 1. But we're not going to put a plus c on the left side. All right? We could, but we just wind up bringing it over to be with the other c. Because what we're working with is we want this to be a pretty basic y and x situation. And guess what? We now have a general solution to our differential equation. So remember from our last 2 days, this is what we would call a general solution. If I want to have a particular solution, then I need an initial condition. So let me give you one, and let's finish this problem. Let's say the initial condition to this problem was we were told that when x equals 1, y equals 1. We'll just make it simple. All right? So if I'm told that when x equals 1, y equals 1, then all I have to do is plug this 1 in for x and plug this 1 in for y and solve for c. So let's do that. So on the left side, I'm going to have 1 to the negative 1 over negative 1 equals 1 cubed over 3 plus c. All right. Well, the left side is just going to be negative 1, isn't it? So this is going to be negative 1 equals 1/3 plus c. And then I need to subtract 1/3 from both sides. So let's see, what is negative 1 minus 1/3? Well, that's negative 3/3 minus 1/3, which is negative 4/3. So negative 4/3 would be my c value. Now, but remember something, we're not technically done with this until we put it back in, right? So let's put it back in to my general solution, okay? So my general solution was y to the negative 1 over negative 1 equals x cubed over 3 plus c. So we now know that my c value was negative 4/3. So now I can say x cubed over 3 minus 4/3 equals, well, this is kind of ugly over here on this left side. All right? Really what I have is I have negative y to the negative 1, which is really negative 1 over y. Something like that. Okay? Now the way that I would finish this problem, we're not really complete until we solve for y. So can't I write this as negative 1 over y equals x cubed minus 4 over 3? Right? And now I have a simple proportion, right, that I can cross multiply. So I have negative 3 equals y times the quantity x squared minus 4 if I just cross multiply like we learned with proportions. All right? That's an x cubed minus 4. Okay? And if we're solving for y, don't I just have one more step? Divide both sides by x cubed minus 4. And I now have y equals negative 3 over x cubed minus 4. And I have finished solving that differential equation down to a, what kind of solution is this? Particular. Okay, and we will stop there for today.